Hello, everybody. This paper is about macroscopic collective interferences formed by individual deterministic events. Here is the abstract. Unlocking the mystery of wave-particle duality is a compelling topic in modern physics. Instead of using the concept of probability, an explanation that can both speak out the individual events and interpret how they are together to construct wave-like complexity is always expected. In this paper, 4 specific examples are given to show that individual deterministic events are indeed able to build up collective interferences in our macroscopic world. Example 1. Collective interferences formed by the left or right motions of the feet of the persons walking along straight-line trajectory. This figure shows a person walking toward the right side along a straight-line trajectory. It's a straight line trajectory. A person walking along this straight line trajectory toward the right side. This figure shows a person walks to a detector screen along a straight line trajectory from a single starting source. The person starts from here along the straight line trajectory to the detector screen here. Of course, the person can also start from here along a straight line trajectory to the detector screen. It can take different diffraction angle state. Now we do a calculation for an individual event at which a person walks from the single starting source and along a straight line trajectory to hit the detector screen. The initial condition is that the person first moves the left foot. When the person reaches the detector screen, the person hits the detector screen either by the person's right foot or by the person's left foot. This figure shows that a person hitting the detector screen by right or left foot. There are 2 possible situations when the person hitting the detector screen. One is by the left foot, the other by the right. If the left foot hitting happens, we assign the number 0 on the point being hit on the detector screen. And if the right foot hitting, the assigned number is 1. This figure shows that the collective interference formed by the left or right motions of the feet of the person from a single starting source and traveling along straight line trajectories. And here the figure shows that 2 persons walking to a detector screen along straight line trajectories from 2 starting sources respectively. Okay, we can see here that 1 person along this straight line and another person along this straight line. And here we can see that a person with 2 possible ways to take. One way is starting from here to the detector screen, and the other way is from here to the detector screen. In computer program, the 2 possibilities are set equal as 50 to 50 in chance. This figure shows the collective interference formed by the left or right motions of the feet of the persons from 2 starting sources respectively and traveling along straight line trajectories. This is example 2. Collective interferences formed by the motions of persons walking along wave-like trajectory. From its figure, we can see that a person walking toward the right side along a wave trajectory. That is like this, a wave-like trajectory from left to the right. This figure shows that a person walks to a detector screen along a wave-like trajectory from a single starting source. The single starting source is here. The person walks along a wave-like trajectory to the detector screen. Here is the detector screen. This figure shows the collective interference formed by persons from a single starting source and walking along wave-like trajectories. Here we can see the collective interference emerge. This figure shows two persons walking to a detector screen along two wave-like trajectory from two starting sources respectively. We can see that one person is from here along a wave-like trajectory to the detector screen, and the other person is from here along the wave-like trajectory to the detector screen. Okay, here, detector screen. Here it shows the collective interference formed by persons from the two starting sources and walking along wave-like trajectory. The y-axis is the number of persons, and the x-axis is the position on the detector screen. Example 3. Collective interference formed by writing pi. This figure shows writing pi from a single starting source. The single starting source is here. We write the pi 3.1415926535897 continue. Finally, a number will hit the detector screen. This figure shows the collective interference formed by writing pi from a single starting source. The y-axis is the representative number. This number is the sum of all the numbers hitting the detector screen. X-axis is the position on the detector screen. Here, it shows two possible starting sources to write pi. One starting source is here. We write pi starting from here to the detector screen. The other starting source is here. We write pi starting from here to the detector screen. This figure shows writing pi from two starting sources. One starting source is here. We write pi from here to the detector screen. The other sources is here. We write pi from here to the detector screen. This figure shows the collective interference formed by writing pi from two starting sources. Example 4. Collective interference formed by persons continuous walking forth and back inside a space interval. Imagine that a group of people walk in a space interval one by one, and every individual person moves forth and back inside the interval. The length of the space interval is 9, and it is composed of 9 subintervals. Each subinterval has a length of 1, and the length of one step every individual person moves is 1. This figure shows that in 1-to-1. In 1-to-1 means the first person moves one step. That means from the starting position here to here, and the person will finally settle down in the position 1. This figure shows event 2. The second person moves 2 steps and finally settles down in the position 2. From here to here, finally settled down at 2. This figure shows event 3. The third person moves 4 steps and finally settles down at the position 4. It's from here to here. This figure is event 4. The fourth person moves 8 steps and finally settles down in the position 8. It's from here to here, 8. This figure shows event 5. The fifth person moves 16 steps and finally settles down at the position 2. It's first moves to 9 and then go back. Finally settles down at the position 2. This figure shows event 3. The sixth person moves 32 steps and finally settles down at the position 4. The starting position is here. The final position is here, 4. This table shows the number of steps and the final positions in the subinterval. This figure shows the representative wave of the collective interference built up by persons' continuous walking or forth and back in the space interval, and the walkings are according to the sequence. This sequence is 1, 2, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6. Thank you.